countdown.
Congratulations! This live broadcast is specially brought to you by Academy YouTuber Malaysia, an initiative by Didik Malaysia and Kelab Guru Malaysia. Please pay attention. The live broadcast will begin shortly. The link to the certificate of attendance will be provided at the end of the session. Please make sure it is filled within the stipulated time. Thank you.
Okay, Assalamualaikum warahmatullahi taala wabarakatuh, and good evening to all teachers, parents, and wonderful students. How's everyone today? Okay, welcome to Pusat Tuisyen Academy YouTuber, a joint venture with Didik Malaysia and Kelab Guru Malaysia. So dengan hashtag bermula percuma, selamanya percuma. So before we proceed, let's begin our session with the recitation of Kitab Al-Fatihah for the Muslim and the moment of silence for the non-Muslim. Al-Fatihah. So how's everyone today? My prayer that everyone is in the best of health and ready to proceed with today's class. Okay? So before we start, let me introduce myself first. My name is Nun binti Muhammad Nur. You can call me Madam Nun. I am lecturer from College Matrikulasi Negeri Sembilan, and I am your moderator for today's class. The most important person today is our passionate and fantastic presenter, Madam Rosmaya. She is very experienced teacher from SMJK Yuhua Kajang Selangor. So let us give a warm welcome to our presenter, Madam Rosmaya. Okay. So for the record, we are now live on Madam Rosmaya channel. So as a sign of support to Madam Rosmaya for the hard work in preparing today's lesson, please subscribe her channel. As usual, the lesson will last approximately 1 hour. So the certificate link and the credit claim link will be given at the end of today's session. So remember that you can only use e-DD email to claim the certificate. For credit claim, you need to collect one letter and 4-digit code which will be announced separately during our class today. So be sure to follow the class up until the end to get the complete code for the credit claim. Okay. I would also like to remind students, if you wish to post comment in the chat box, please use appropriate language and use appropriate profile picture. I am pretty sure all of students here are excellent students who will uphold a positive classroom environment. Please give your full cooperation in making this class a lively one. Stay focused, and if you have any question, just write in on the chat box, so we will try to provide you with the answers. Before I give to Madam Rosmaya to present, I will announce the first digit code for the credit claim. So the digit is, please listen carefully, A16. A16. Okay? Again, A16. That's our first digit code. So without further ado, please welcome Madam Rosmaya to start her presentation today. Okay, Madam Rosmaya.
Okay, thank you, Cikgu Nun, our moderator for today. Okay, Assalamualaikum and good evening everyone. So I'm Madam Rosmaya. So I will guide you all through this live session on the topic pressure of a gas and Rms speed of molecules. Rms speed of gas molecules. Okay, so we are going to solve a few problems related to this topic also. Okay, so before I begin, I would like to introduce Prayu team, in the Academy YouTuber. Okay, so the first team here shown is Maths team, lead by teacher Im. Okay, the second team we have is biology team, lead by Cikgu Faiza. Okay, the third team is chemistry, lead by Cikgu Shahnun. And the last team is perakaunan dan ekonomi, lead by Madam Fizi. We also have other STPM subjects like pengajian MURID, pengajian perniagaan, perakaunan. Also this one include in our pre-U teams. Okay, so let's start our discussion now. Okay, so this is the learning objective, okay, for today. So we are going to prove the formulas, okay, of pressure of gas. So these three formulas. And the next one is we are going to prove the formulas for the Rms speed. Okay, given here three formulas we are going to prove. And then we are going to do some problem solving. And we are going also to use the previous formula that we've learned. Okay, recall this formula. PV equals to nRT, and another related formula to PV equals to nRT, which is PV equals to nKT. We use Boltzmann constant here, K, or you can use the n here as the n per Na, or the n here number of mole as m per molar mass here. So this is mass of a gas. So we start with the our first target, our first objective, to prove the formula of a pressure of a gas. Okay. So for pressure of a gas, we start with the we start by imagining okay, the gas trapped in a cuboid here, cuboid container. Okay, so the cuboid container has length L. Okay, number of molecules inside the cuboid container here, N, and then the mass of a molecule is M. So this is mass of a molecule, one molecule M, and then velocity C, velocity of all the molecules here. Okay, velocity of one molecule. Then let's say we divide into three direction of the velocity, U, V, and W. So U, V, and W is the component of this velocity, okay, of the of a molecule here. U, V, W. Okay, next we start with the change in momentum along OX. We start with the U direction first. So the change in momentum along OX will be mu. Momentum is mass time velocity. Okay, you've learned in form 4, form 5. So momentum, mass time velocity. So mu in one direction. So minus the negative mu in another direction. So total, when we calculate the change in, we get 2 mu. Okay, hi Chia Ying. Okay, you are here with us today. Okay, welcome to physics class. Okay, from here we continue with the time taken, because we are going to combine these two. Okay, so time taken is equals to distance divided by velocity. So the distance traveled by the molecule along OX here will be 2L. 2L because the length of the cuboid is L, right? So to and fro, so we get 2L divided by the velocity U, component along OX. Okay, now we combine these two, change in momentum. Over time, we get rate of change of momentum. So the meaning rate here means we divide by the time. That's why we calculate time here. So change in momentum divided by time taken. So we substitute these two into here. So simplify. So we get mu squared per L. Okay, now next step, we are going to relate this with pressure, right? So we are going to use Newton's second law, okay, where rate of change of momentum is the force. Okay, so what is force? Force is rate of change of momentum. Okay, now this is for one molecule. So if we have n molecules, so we total up all the u1 squared plus u2 squared plus dot 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 plus un squared. This is for n number of molecules, and then times the m per L. So this m per L. Just continue from here. So we get total of force. Okay, now how to get pressure from this force? Okay, so pressure is force divided by area. Okay, pressure is force divided by area. Okay, now this total force divided by the area, this is the cuboid, so that means the surface area will be L times L, so L squared. Okay, so the force divided by area. Now we simplify this. Okay, so L times L squared, we get L cubed. Then the rest here remain the same. Okay, next step, continue from here. Now we are going to use the mean square speed, because this is too long, right, to write if we have n number of molecules. So we just get or calculate the mean square speed. So mean square speed relate with this one. So mean square speed is given by the total of square of the velocity divided by n. So this is mean square speed. So when we cross multiply, so substitute into here. So you get m per L cube. Here remain the same. Okay, this one will become n mean square speed. Okay, so you cross multiply here, so you get this. Okay, next we just join this together, the same thing. Okay, we just join this together. So nm mean square speed per L cube. So what is L cube? Okay, L cube is L cube is volume. So before that, we are going to relate with C. C first. So the mean square speed is the total of the u, the is velocity along OX, and then plus v along OY, and then W along OZ. So total then up, so we get mean square speed. And this means this mu u squared plus v squared plus w squared is all the same, because there are large number of molecules and they move randomly, so we can consider that they are all the same. So we just choose one, let's say u, okay, because we are going to substitute into here, right? So we just use all as u. Here v squared is u squared, w squared equals to u squared. So that's mean we have mean square speed equals to 3 the square speed along OX. So now we can substitute into here. So here we cross multiply, we get 1 per 3 mean square speed. So now we can substitute into here. So we get nm mean square speed per 3L cube. And then this L cube is the volume. L times L times L of the cuboid here will give you volume. So we prove one formula. Okay. So now from this formula, okay, mass per volume is the density. So there are m is mass of one molecule. So we have n molecules altogether trapped in the gas here, in the container here. So that means n times m per v will give you density. Okay. So this is another formula of pressure, can be memorized, depends on the what given in the question. Okay, so pressure equals to density 1 per 3 density mean square speed. Okay, next formula we are going to derive is this one, n per v. Okay, so n per v is we use small letter to represent n per v. So n per v is number density. Okay, so memorize these three formulas for the question in the exam. So we are going to use these three formulas. I will give you example later. So now what is this n is now? N is number density. So don't confuse this symbol n with the number of moles. Number of mole. Okay, some of you when you use this formula in the exam, so you always refer this n as a number of moles. So you must really be careful. Okay, so this n is not number of moles, but this n is number of density. And then this m, remember, this is mass of a molecule. Okay, one molecule, not the mass of a gas. Okay, and then rho is density, and this is a mean square speed. Okay, let's try this example. Okay, so example, the mass of gas in cylinder of volume 0.050 meter cube is 0.062 kilogram. So the pressure of the gas is 1.5 times 10 to the power of 5 Pascal. So estimate the RMS speed of the gas molecules. Okay, so the solution is, we are going to use this formula first. Okay, so first identify what is given in the question. Okay, so you are given the volume, okay, this volume, and then this mass. Okay, be careful. This mass is mass of gas. This is where you will make careless mistake on this M. So the mass given here 0.062 kilogram is the mass of gas. And then the pressure is given 1.5 times 10 to the power 5 Pascal. And then we are going to find the RMS speed. Okay, RMS speed is means root mean square. But this one is the mean square. The c squared here is the mean square speed. So for the root mean square speed, so that means is a square root of this mean square speed. Okay, so we use this formula first. Okay, because the mass the mass here is mass of a gas, so we cannot use these two formulas because this M, I repeat again, this M is mass for the one molecule. Okay, whereas given in the question is 0.062 is mass of the gas, so we choose this equation instead. Okay, now how to relate this density with this mass? So this density is mass per volume. This mass can use this mass. Okay, so you substitute this value into here, and then the volume, so you get density. Then you can substitute into the equation here. Okay, combine all this equation, so you get this and cross multiply, so you get 3 Vp per m. Okay, so it's up to you whether to substitute at the early part, or you want to substitute it later. So now what I give you here is we are going to substitute now here. Okay. Now, okay, like I said just now, what is root mean square speed? RMS is stand for the root mean square. So the root mean square speed, here lah, the square root of the mean square speed. Okay, so this is one of the formula for the RMS speed. We can make use of the three equations just now we proved to get the RMS speed. Okay, so we substitute this into here. Okay, now substitution part. So substitute everything. V this one is pressure. 1.5 times 10 to the power 5. Then pressure volume 0.050 meter cube already in the SI unit, and the mass here 0.062. So the answer is 600 meter per second. So this is RMS speed of the gas molecule. Okay, so next next is we are going to relate this with RMS speed of molecules. Okay, RMS speed of molecules. Okay, this one we've done already. What is the RMS speed or root mean square speed? So root mean square speed is a square root of mean square speed. So this mean square speed we can also calculate from these three formulas, and then we can take the square root to get the RMS speed. Okay, now we continue. The mean square speed. What is the mean square speed? Okay, so the mean square speed is equals to the C1 squared plus C2 squared plus ... until Cn squared divided by n. So this is what is meant by the mean square speed. So we are going to prove another formula for the root mean square speed, which is square root of 3 kT per m. Okay. So there are three formulas just now. So we prove this first, 3 kT per m. Okay, so we are going to take from here, okay, to get this. As I said just now, the mean square speed actually we can get from here, right? So now to prove that the RMS speed is square root of 3 kt per m, so we choose one of the equation here. Okay, this one. Okay, now we are going to substitute the cross multiply. Okay, V here cross multiply here becomes PV. So we are going to use the PV equals to nRT now. Because this is KT, so we choose PV equals to nKT. Okay, T is the absolute temperature. So that means T must be in the Kelvin unit. K is the Boltzmann constant. N is the number of molecules of the gas. P is the pressure. V is the volume of the gas. Okay, so now combine these two or equate these two. Okay, equate these two. We use simultaneous equation. So we get this. We get this. And then we can cancel one of the N. Okay. Then, okay, cross multiply 3 kt. And the mean square speed. So that means we need to bring M to the other side. So it is proven that mean square speed is equals to the square root, RMS speed, because RMS speed is a square root of this one, right? Square root of the mean square speed. So we put square root. So it is proven that RMS speed is 3 kt, square root of 3 kt per m. Okay.
Okay, Madam Rosmaya, can I announce the second digit code for a while?
Okay. Hmm.
Okay, class.
Ready?
Our second digit code, please write down somewhere. So our second digit code is number 2. Okay,
Okay,
our
number 2.
second digit code is number 2. You need to write down somewhere. Yes. Okay, thank you, Madam Rosmaya. You can continue.
Okay, so now we continue with the second equation from the RMS speed. Okay, this is the first equation for RMS speed. The second one is square root of 3 RT per molar mass. R is the 8.31. If you can remember the previous lesson. Okay, and 3 RT per m, the capital letter M here is the molar mass. Okay, so now for the next one, we will use this one. We'll use this one. Okay, to uh, to derive this equation, square root of 3 RT per molar mass. Okay, so sometimes in the exam, they ask you to derive the equation. So this is the method. Okay, continue from here. So again, we are going to relate this with the PV equals to nRT. So one of the equation, the N, number of moles, is M per molar mass. Mass of a gas, okay, divided by molar mass. So you can get the number of moles. Okay, now we combine these two. Okay, combine these two. MRT per M equals to 1 per 3. Mass is M per volume, right? So M per volume, I didn't do here. So density is mass per volume. So cross multiply, we get PV. So that's why we can equate these two. Okay. So no more density here because the density here is mass per volume. So equate these two. Then you cancel the M. Okay, both M is the mass for the mass of a gas. Then we cross multiply, so you get mean square speed equals to 3 RT per m molar mass. Okay, so now what is RMS speed? So RMS speed is the square of the mean square speed. So you square this, so it is proven that the RMS speed is square root of 3 RT per molar mass. Okay, done for the two equations. Okay, so next, what is the last one? Okay, these two done already. Then the last one, the mean square speed, the RMS speed. Okay, sometimes we get confused. The mean square speed and RMS speed. RMS speed is the root mean square. Root mean square speed. Okay, so the RMS speed is the square root of 3p per row. So what do you think? Where this come from this 3? Okay, so if there is a density there, so it must come from this equation, right? So continue, we choose this also. This one very easy to get actually. So we choose from here. Okay, so you just rearrange the equation here. So you get mean square speed first, mean square speed. So cross multiply. Okay, so 3p per density. Okay, then for the RMS speed, it is equals to the square root of the mean square speed. Okay, so there we get, we prove the equation. Okay, so we've done for the derivation part. Okay, done for the derivation part. Okay, next we try one question. So example 1. Calculate the root mean square RMS speed in meters per second, okay, of argon atoms at 27 degrees. Okay, so you can choose either one. So let's choose this one first. So whatever equation you choose depends on the data given from the question. And then sometimes can use more than one equation. Sometimes can use more than one equation. So let's say we choose this equation. Okay. Now you substitute the given value 3 R is 8.314. You can get this from your calculator also, and sometimes in the question for constant they give you in the exam. So do not worry, or you can get it from your calculator constant. So 3 times 8.314, and then remember that the temperature here must be converted to SI unit. So given here is 27 degrees Celsius. Okay, Celsius here didn't give typing error. Here got typing error. So the 27 degrees Celsius convert to absolute temperature Kelvin. So 27 plus 273. So you get the temperature in Kelvin. Okay, so now the molar mass. So we don't know the molar mass. So you refer this molar mass to the periodic table. Okay, from the periodic table, so search for argon. Search for argon. So the value here is 0. The value here is in gram per mole. Gram per mole. So it's about 39.95 gram per mole. So you convert to kilogram. Okay, kilogram per mole. So substitute this molar mass into here. Okay, so 0.03995, but make sure you convert it to kilogram. Okay, kilogram per mole, because this is molar mass. So automatic or directly can substitute into here. So you get 433 meter per second. Okay, so that's the answer. Okay. Okay, we have another student here. Oh, Chia Yao. Okay, I'm fine. Okay, now we go to the next question. We try to next question. Before we try next question, what do you think? The use of RMS speed. Okay, what is the use of RMS speed actually? So the use of RMS speed is we can predict how fast the molecules are moving at the given temperature, and we can compare between the two types or more types of gas. For example, the isotope of certain gas. Okay, so RMS speed is used to predict how fast molecules are moving at a given temperature. So we are going to discuss the use here in the next question. Okay, next question. Okay, this question take quite long to solve. So I think Madam Nun, we can take a rest for a while with the iklan. Can
Okay, Madam Rosmaya? Yes. Okay, we can see the advertisement first. Okay, all right.
Berita baik untuk semua. Kini, Akademi YouTuber memperkenalkan sistem mata ganjaran kredit AYU untuk dikumpul. Jom ikuti kelas tuition live AYU untuk mengumpul kredit AYU dan berpeluang menebus hadiah-hadiah yang menarik. Hadiah bernilai lebih RM10,000 disediakan secara percuma untuk pelajar seluruh Malaysia. Apa tunggu lagi? Tebus ganjaran hebat ini sekarang. Layari www.academyyoutuber.com untuk maklumat lanjut.
Okay, Madam Rosmaya, you can continue.
Okay,
Thank you.
Thank you, Madam Nun. Okay, so let's continue. And I can see from the chat box there, we have Cikgu Faizah with us, okay, in the chat box. So, Cikgu Faizah is one of the pre-U team in the bio. She is the head of the bio team, okay, biology team in the Academy YouTuber. Okay, thank you, Cikgu Faizah, for joining physics class today. Okay, so we go to this question now. We discuss this question now. Okay, we read the question first. Uranium has two common isotopes with atomic masses of 238 and 235. Okay, so one way to separate these isotopes is to combine the uranium with the fluorine to make uranium hexafluoride gas, okay, given by UF6. So then exploit the difference in the average thermal speeds of molecules containing the different isotopes. So we are going to calculate the Rms speed of each type of the molecule at room temperature. Okay, these two isotopes. Then we can compare the speed, Rms speed. Okay, so now we are going, this time we use this equation. Rms speed equals to square root of 3 kT per m. Okay, so now the problem is same. We don't know m. M. So K is 1.38 times 10 to the power of negative 3, Boltzmann constant. So temperature at room temperature, here mentioned room temperature. So let's take the room temperature as 27. So plus 273, converted to this temperature is converted to Kelvin. Okay, now the problem is M. Remember that what is this M? I said earlier of this our session. So the M is mass of one molecule. So we need to find the mass of one molecule. Okay, so how to find this M, mass of one molecule? So we do one by one first. We solve for uranium-235. We solve for uranium-235. So for uranium-235, the uranium hexafluoride gas, okay, UF6, give you, okay, you total up the gram per mole. Here reading for the fluorine, you need to read from the periodic table. So uranium-235 is given here, 235, and then plus 6 atom of fluorine. So you get it from the periodic table. Okay, so the reading there, okay, give you about 19 gram per mole. Okay, 19 gram per mole. Okay, so this is the molar mass, 19 gram per mole. So it's for 19 gram per mole. So total up, this uranium hexafluoride gas, so it give you 349 gram per mole. So this is for 1 mole. But the M here is mass for one molecule. So you need to do further calculation here to get the mass for one molecule. So that's why we need to use Avogadro number. So Avogadro number for 1 mole of gas, there are Na, Avogadro number 6.02 times 10 to the 23 molecules for 1 mole. So therefore, to get the mass, So that's mean this molar mass divided by Avogadro number. So you get the mass for one molecule. So convert to gram here, convert to kilogram. So you get 5.79 times 10 to the power of negative 25 kilogram per molecule. So this is the mass that we are going to substitute here. So this is where you need to be careful. The M here is mass for one molecule, right? For one molecule. Okay, now you solve this equation, value. You get RMS speed as 146.461 meter per second. Okay, so this is for uranium 235. So now we do the same for uranium 238. Okay, so we keep this for a while because next, using the same method, oh yes, Valamati Ganesan. But we need Valamati, correct? 1.146 meter per second. Okay, but you need to write it in larger number because we are going to compare later. Compare later. Okay. So we do for uranium 238 the same method as just now. Okay, so what is this M for the 238 for 238 uranium 238. So 238 plus 6 of the fluorine, so 19 19. So you get 352 gram per mole. Okay, so we substitute into the mass of one molecule. We use molar mass divided by Avogadro number. Okay, so the answer is 5.84 times 10 to the power of negative 25 kilogram per molecule. So this is mass of one molecule. So substitute into here. So you get the answer 145.833 meter per second. So do you realize that it's almost, you cannot round off too early. If you round off this 146, here also you round off, you get 146. So you get equal in number. So you must write in a larger number of significant figures for comparison. Okay, so this is what we get. So now you can see clearly that which one is faster. At room temperature, which one move faster. So that is what the use of the RMS speed. So it is found that uranium 235 is faster than uranium 238 at room temperature. Okay, so this is one of the use of the RMS speed. Okay, next we've done this. Okay, let's try another question. Okay, another question. So the root mean square speed of gas molecules is 256 meter per second. Okay, at given T. So temperature here not given. Just mention as T. Then the gas has a molar mass of 32.00 gram per mole. Okay, so what would be the root mean square speed for a gas with a molar mass of 131.0 gram per mole? Okay, so you are given molar mass. So if you are given molar mass, so which one to be used? Which equation we can use here? Okay, so we can use the one that has molar mass lah. This one. Okay. So we use this equation, and then the mean square speed for the first gas is given at this temperature, but for the second gas we don't know. We are going to find the root mean square speed for C. We name as C2. Okay, this is for the first gas. We name as M1, molar mass for the first gas, and this one is the molar mass for the second gas. Not mention the gas, and at the same temperature. At the same temperature. So we can use this formula because it's easier. It got molar mass there in the equation. Okay, so what method can we use here? So this is common method we use in almost that involve calculation. Question that involve calculation. So we can use ratio method here. Ratio method. So for the CRMS, because R is constant, T is a numerical value, so constant, T also constant. So that's mean the RMS speed here is directly proportional of square root of 1 per m here. Okay, or we can say RMS speed is inversely proportional to the square root of m. Okay, so we use ratio method. Okay, you've learned this in the form 5 maths variation topic, right? So you can use that method, or you can use the simultaneous equation also can. So use ratio method is better. Okay, simplify this because this is inversely, so that's mean C1 per C2, RMS1, RMS C1 per RMS C2 equals to square root of M2 per M1. Okay, because it's inversely. Okay, so you form this equation. Okay, so then you substitute lah everything here. So C1 is 256. So RMS2, C RMS2. Then the square root of M2 is 131. M1 is 32. So you get the answer. RMS speed is 126.5 meter per second. Eh? So that's mean at the
Okay,
same
Madam
temperature.
Rosmaya.
Yes. Ha.
No, I think that I want to announce. I thought you are finished. Okay, you can continue because after this I want to
Uh,
announce the third digit code.
okay, can
Okay,
announce
all right.
now.
Okay, okay. Hi everyone. Hi student. Okay, our third digit code is number 9. Okay, number
Okay.
9. All right. So, Madam Rosmaya, you can continue. Sorry. Thank you so much.
It's okay. Okay, so if you compare these two value of RMS speed, 256, this one is 126. So that's mean the first gas molecules here not mentioned here is faster than the second gas in the given temperature. Okay. Okay. So that's mean we finish early today actually, because I prepared for today's pressure of a gas and the what you call that, the RMS speed. So I think we can stop now, and that's all for the discussion for today. Okay, so I give back to
Okay.
Madam now.
Okay, Alhamdulillah. We have reached the end of today's session. Congratulations to those who can follow our session from beginning till the end. So before we end our session for today, I will announce the fourth or the last digit code for the credit claim. So the digit code is number 4. Okay.
Number
Just now
4.
I announced the third. Yes, this is the fourth digit, which is number 4. So all of you, please stop posting your comment for a while. And if you haven't clicked the subscribe button, please do so. Make sure that it turns to gray color, okay? And activate the icon bell so that you will not miss the next class session. Then, if you find that the lesson was beneficial, click like and share to to click like and share to your friends on your social media. Spread and share the goodness. Okay, once complete, type done on the chat box before the certificate link is given as a token of thank you for your dedication in joining the free online to this class. Okay, so I will give you the link for the wait okay, that's the link to claim the credit, and then link for the uh, certificate, and you make sure that you use the email EDD. Okay, sorry, yeah. Okay, guna just use the email EDD to NMOE. Okay, to claim the credit. Okay, I hope that all the information is in the chat box. Okay, I hope you can use it. You can feel it after this. So if you wish to get more information about the online class, you can go to the Academy YouTuber as the given link there. And for those who not join EDD Junior Telegram, please do so. So once again, I would like to thank all of you for joining our tuition class today. Remember that the more classes you join, the more credit you can claim. Okay. Feel free to share the free tuition class to your friends and teachers all over Malaysia. This is a collective effort from all teachers throughout Malaysia for all the students throughout the country. Thank you too for being a YouTuber Academy supporter. I think that's all for now. See you in another session. Do not forget to the hashtag bermula percuma, selamanya percuma. Stay safe till we'll meet again next time, same day and same time. Thank you very much everyone and assalamualaikum. Okay, bye.
Wow, banyaknya hadiah menarik menanti anda.
Wah, kini Akademi YouTuber mengambil inisiatif baru di mana memberikan hadiah-hadiah ini secara percuma. Ya, percuma kepada anda semua. Bagaimana caranya? Dengan mengikuti kelas tuition online percuma Akademi YouTuber sambil mengutip mata kredit, anda dapat menukarkannya dengan hadiah-hadiah yang menarik ini. Tunggu apa lagi? Segalanya percuma.
Jangan lepaskan peluang tau. Dah dapat banyak hadiah menarik, takkan nak lepaskan peluang.
Layari www.academyyoutuber.com sekarang untuk maklumat lanjut.
Dibawakan kepada anda oleh Akademi YouTuber.